Hi, my name is Kaylee, and you're watching the Youth Code Jam Bits and Bytes Puzzle Club Week 2 video. In this video, we'll be going over some of the puzzles that we did today as a group, in case you get stuck on working some of your own or you would just like a refresher. We'll be looking at knights and knaves puzzles today. So this is how knights and knaves puzzles work. You will be given statements from each person. There will be a couple people in the puzzle. And there are two kinds of people. Knights always tell the truth and knaves always lie. If a person is a knight, we know that their statements are always true. And if the person is a knave, then we know that what they say is always false. It's always a lie. And it's your job to figure out who is a knight and who is a knave. So who's telling the truth and who's lying. And here are some strategies for solving knights and knaves puzzles. We should look through all of the possible scenarios and eliminate the ones that aren't possible. And we'll use a truth table to keep track of everything. Here's our first example. A very special island is inhabited only by knights and knaves. Knights always tell the truth, and knaves always lie. You meet three inhabitants, Alice, Rex, and Bob. Alice tells you that Rex is a knave. Rex tells you that it's false, that Bob is a knave. Bob claims, I am a knight, or Alice is a knight. Now, it looks really confusing, just kind of in a block like that. So let's pull out the statements that we're working with, and so that we can see them a bit closer. Alice's statements first is that Alice tells you that Rex is a knave. And so we have here, Alice says Rex is a knave. Rex is next, and he tells you it's false that Bob is a knave. So in other words, Rex is saying Bob is not a knave. Bob claims, I am a knight, or Alice is a knight. And we've copied that here. Bob says, I am a knight, or Alice is a knight. And now we're going to try to figure out who is lying and who's telling the truth. But in order to figure that out, first we need to make an assumption. And we're going to label it an assumption because it's kind of like a guess, and we're not sure. So since Alice is first, let's make a guess about her. We'll assume that she's a knight and see what happens. So we'll assume that Alice is a knight, which means that Alice tells the truth. And if Alice is a knight, then we know that what she says here is true, which means that Rex is a knave. Rex lies. And if Rex lies, we know that what Rex says here is not true. What is true is the opposite. So if he's telling a lie, then the opposite of what he says is the truth. Well, what's the opposite of Bob is not a knave? The opposite would be Bob is a knave. And so we've written that here. So if Bob is a knave and Bob lies, then the opposite of what Bob is saying here is true because he's lying. But Bob's statement is kind of complicated. So what we have to do is take the opposite of all three parts of his statement. The three parts are I am a knight, meaning Bob is a knight, the opposite of or, and the opposite of Alice is a knight. So the opposite of I am a knight ends up being Bob is not a knight. The opposite of or is and the opposite of Alice is a knight is that Alice is not a knight. Now, one at a time, we'll look for contradictions. A contradiction is just like two pieces of information that say opposite things. They can't both be true. And so if we find a contradiction, then we know that our assumption was wrong and that we probably need to start over. So this first statement says, Alice is a knight. Do we see anything in the rest of our conclusions that talks about Alice that might be a contradiction? This bit here contradicts. So our assumption says Alice is a knight, but this statement here says Alice is not a knight. We have a contradiction, so our assumption is probably wrong. What we have to do is change our assumption. So we assume that Alice is a knight. Now let's try assuming that Alice is a knave, meaning Alice tells lies. And we'll solve the puzzle using that assumption again and see if that leads us to the answer. So if Alice is a knave, which means she tells lies, then what she says here is a lie. And so if Rex is not a knave, what is he? Rex is a knight who tells the truth. And we know that if Rex tells the truth, then his statement here is true. Bob is not a knave. If Bob is not a knave, what is he? Bob is a knight, who tells the truth also. And if Bob is a knight who tells the truth, everything here in his statement is true. He is a knight or Alice is a knight, and we can copy that down here. Now let's check for contradictions again. We want to be sure that our assumption was correct. So we'll look at this that says Alice is a knave, and do we see any contradictions? You might think, well, what about this over here that says Alice is a knight? But in fact, it's not a contradiction. Do you see this or right here? The or means that one or the other has to be true. And it's possible that this one's true. In fact, Bob is a knight right here tells us that Bob is a knight. So if there's at least one true thing on either side of this or, then we're fine. So this is not a contradiction. We're still okay. And our first statement looks like it's true. Let's go on to our second statement. Rex is a knight. I don't see anything else that's talking about Rex down here, so we're good to go. This one says Bob is a knight, which doesn't, the only other place I see Bob is right here, and that doesn't contradict, so we're fine. And now we're on the last statement. And remember, in order for an or statement to be true, either Bob has to be a knight or Alice has to be a knight. They don't both have to be knights because it doesn't say and, it says or. And so since Bob is a knight, which we know from here, then the entire statement is true. And we're good to go there. Everything checks out. There are no contradictions this time. So we know that Alice is a knave, that Rex is a knight, that Bob is a knight. Nice work. Let's look at our second example. You meet two inhabitants. I'm looking over here at the left. Zed and Bart. Zed says, Bart is a knight or I am a knight. Bart tells you, Zed could claim that I am a knave. That's kind of confusing, so let's pull out all of our statements one by one. First, Zed. Zed says, Bart is a knight or I am a knight. So we'll copy that over there on the right. And then we have Bart. Bart tells you, Zed could claim that I am a knave. And let's put that here. Okay? Now let's make an assumption and work through the problem and see if that leads us to the answer. So I'm going to assume that Bart is a knight, that Bart tells the truth. And so if Bart tells the truth, then the statement that Bart makes is true. So Zed could claim that Bart is a knave. But we know that Bart is not a knave right here. So to claim that Bart is a knave, Zed would have to lie or be a liar, which means that Zed is a knave. So we have our conclusion here, Zed is a knave. So then we have Zed's statement here, Bart is a knight or I am a knight. If Zed lies, then this statement is false. And the opposite of his statement is true. So we need to find the opposite of each part of this statement. There's three parts. Bart is a knight, or, and I am a knight. We need to find the opposite of each. So down here with our conclusions, we'll find the opposite of Bart is a knight, which is Bart is a knave. The opposite of or, which for us is and the opposite of I, Zed, am a knight, which is that Zed is a knave. Now let's check for contradictions and see if our assumption was right. We'll look at our first statement. Assume Bart is a knight. Do I see any contradictions with that? Yes, I do. So this statement says Bart is a knight, and this statement says Bart is a knave. But Bart can't be a knight and also be a knave, so we have a contradiction, which means that our assumption was probably wrong. So let's assume the opposite and try again. Instead of assuming Bart is a knight, let's assume that Bart is a knave, that he lies. Okay, now let's go through the statements. If we know that Bart lies, then his statement here is a lie. And Zed could not claim that Bart is a knave. But we know that Bart is a knave. So if Zed can't claim that Bart is a knave, if Zed can't tell the truth, then Zed must be a liar. So we have our conclusion, Zed is a knave, or Zed lies. And if Zed lies, we know that his statement here is a lie. And much like before, the opposite of each part of this is true. The opposite of Bart is a knight, the opposite of or, and the opposite of I, Zed, am a knight. So we have our statement here that's the opposite. We've taken the opposite of each of these three parts, which brings us to Bart is a knave and Zed is a knave. Now let's check for contradictions. Assume Bart is a knave. So this says Bart is a knave, and even though I have a typo here, this also says that Bart is a knave. I don't see any contradictions, so it looks like the statement is good to go. Let's look at our second statement. Zed is a knave. The only other time I see Zed's name come up in our conclusions is right here, which also confirms that Zed is a knave. So no contradictions here. And finally, our last statement. Bart is a knave and Zed is a knave. Bart and Zed have to be knaves in order for the statement to be true, and that lines up with our first two statements here. So this statement is also good. Great job, no contradictions, so we know that everything here works out. And as far as who's a knight and who's a knave, we know that Bart is a knave and Zed is a knave. Great job, y'all. Thank you so much for watching this video today. If you enjoyed working through these puzzles, there are some things that you can do as next steps. So one, you could share this video with a friend who also likes puzzles, and maybe that will inspire them to try out some knights and knaves puzzles of their own. You could go to the website listed here for more puzzles like these ones, the knights and knave puzzles. And you could come to our Bits and Bytes live session next Monday to work through some more different kinds of puzzles together. Thank you so much for watching, and I hope you had fun. I'll see you next time.